Discussing briefly the binomial distribution. A distribution is binomial if four characteristics are met, and they're listed right here. The acronym is BINS, B-I-N-S. The binary means that each outcome is either a success or a failure, a yes or a no, a girl or a boy, an up or a down, a heads or a tails. If you can have it as two outcomes, on only two outcomes, then you can call it binary. Uh, so it could be that you need to combine some things. So you might say, instead of all the possible grades on a test, you say an A or not an A. Or you say, we're going to, of all the ways that a baseball player could get to first base, you could say it was a hit or not a hit. But you've got to make it down to two options. Each trial has to be independent. That's what the I is, so that knowing one doesn't tell us anything about the other. We have a fixed number of trials. That's N. That's the number of times you try to do it. And S, the probability of success is the same each time. So consider rolling a die, and we're going to roll the die, we'll say 10 times, and the probability of getting a 3 is 1/6. Every time you roll a die, it's either a 3 or it's not a 3, so that is binary, and the trials are independent because the die doesn't know what's going on. So the formula looks like this. The probability, the number of 3s that I would roll in my 10 tries is 4, is going to be found by doing this. This is the formula: 10, choose 4. I don't know if we'll have to do the formula on the test, but it is on the formula chart, and so here's how it works. 10, choose 4. And then the probability of success is 1/6, and I succeeded 4 times. And the probability I failed is 5/6, and I failed 6 times, right? Because if I succeeded 4 times, I had to fail 6 times because I did it a total of 10 times. And I could do this on my calculator with the, go back to a pen here. I could do this on my calculator with a binomial function. This is the binom PDF. 10 tries, that's N. P is 1/6, and X is 4. Now this is similar to this case. The probability X is less than or equal to 4. And the formula here is going to be what I've written before several times. So it's 10 choose 4, blah, 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 plus 10 choose 3, plus 10 choose 2, plus 10 choose 1, because this is really just the probability I get no wins, plus the probability I get 1 win, or 1 3, plus the probability it happens twice, up here to what I found on that first part. And this would be more easily done with the binom CDF function, and the same idea here. And that would just give you a cumulative answer. So this is kind of an overview. Now, the other two things that you have for a binomial distribution are the mean and the standard deviation. And these formulas are on the formula chart, cleverly labeled for a binomial distribution, yada, yada, yada. The mean of x is NP. So for the example I gave, that means if I tried it 10 times and the probability of success is 1/6, then I should expect that number of successes on average. Here's what that means. I get all the students, all of you guys roll a fair die 10 times, and you count how many 3s you got. This number will be the average for a very, very, very large group of minions rolling this die. And then the standard deviation for this problem, again for a binomial distribution, is the square root of NP 1 minus P. Or for my problem, it's the square root of 10 times 1/6 times 5/6. And that basically tells me, again, in the same classroom full of minions rolling the die, how different are all of your numbers. Not how different are the numbers when you roll it, how different are the numbers that you tell me, which account for how many 3s you got out of 10 rolls. So everybody rolls the die 10 times. You count how many 3s you got. You start telling me your answers. Most people have 1 or 2 or 3 3s in that group of 10. Maybe somebody had no 3s, it'd be very, very unlikely that somebody had 9 or 10 threes. But if I take all those numbers and average them, I get that mean. And if I take the standard deviation of all those numbers, I get that standard deviation.